Mic check, mic check. Okay, here you go. All right, number one, whenever you factor. So difference of squares is x minus 2, x plus 2, all over x plus 2. All about factoring there. All right. And then when you cross the x plus 2's out, you just get the f of x is equal to x minus 2. All right. But remember that there's a hole at what? X plus 2 is equal to 0. So x is equal to negative 2 is where the hole is. And remember, a hole is a point. So you could plug in negative 2 into the new function here. If you want to, you don't have to right now, but so this is going to equal negative 4, right? So the f of negative 2 is going to equal negative 4. So our hole is going to be at negative 2, negative 4. How do we graph this? Makes it easy because you have to just graph a linear function. So just go down 2, 1, 2, and then slope is 1. You just go up 1, right 1, and this is your graph right here. And make sure, again, at negative 2 and 4, you just negative 2, 4, 1, 2, 3, 4. Right here, just put a hole right there. May want to erase that. Yeah. That's your answer. Okay. Any questions on that? Not too hard, I'm hoping. That first part, again, as long as you factor well, should be okay. You don't need to do the, the asymptotes or anything like that because you simplified it to a linear equation. So all right, oh shoot, I forgot to share the screen. Dang it. All right. Sorry, I forgot to share the screen, but this is your answer for number 1. You cancel. You have f of x equal to negative 2. You go down 2 for the y-intercept. You go up 1, right 1, graph the line, and then draw a hole at negative 2, negative 4. That's what I did here. Okay. All right, number 2 is this right here. It is x minus 4 on top, and then you have x squared minus 3x. So I'm gonna write it over here. I'm gonna factor this x and then x minus 3. And we're gonna have vertical asymptotes on this one. You can't cancel or anything like that. So we're gonna have vertical asymptotes is what? X is equal to 0 and x minus 3 is equal to 0. And so x is equal to 3. And remember that vertical asymptotes are lines. It's not a point. Okay, so with 0, x equals 0, you're gonna go along the y-axis right here. And x equaling 3, you're gonna go 1, 2, and 3, and you're gonna draw. I'm gonna go a little bit. I'm gonna space it out a little bit more. I'm gonna go every 2. So this is 1. This is 2. This is 3. All right. All right. The power horizontal asymptote is the value on the bottom is bigger than the power on the bottom is bigger than the power on top. Correct. So in that situation, what do we have? We have the n is so y is equal to 0, right? The horizontal asymptote rule. The power in the denominator is bigger than the power in the numerator. So y is equal to 0. Okay. So in this situation, we're going to draw a horizontal asymptote at y equals 0. Okay. Then we want to get the x and y intercepts. Okay, the x-intercepts is where y is equal to 0, right? And this is it's a line. Remember, these are points. And the y-intercept is where x is equal to 0. Okay, so let's get the x-intercept first. The x-intercept is where y is equal to 0. So remember, you make the numerator equal to 0. So x minus 4 is equal to 0. Add 4 to both sides. And what do you have here? You have x is equal to 4. So 4, 0 is our x, our x-intercept right here. For the y-intercept, I'm going to separate this out. For the y-intercept, you're going to plug in 0 for the equation here. So it'll be 0 minus 4 over 0 times 0 minus 3. It's going to be negative 4 over negative 3, which is just 4 over 3. So at the y-intercept will be 0 and then 4 over 3. There's again?
Wouldn't be negative 4 over 0.
Negative 4 over 0. Oh, you're right. You're right. Thank you. Sorry, because I was looking at this. My bad. Thank you. So it will be undefined then, right? Thank you. And that makes sense, right? That makes sense, right? Because the y-axis is the asymptote. So thank you. So there is no y-intercept. So 4, 0 is the x-intercept. That's interesting. Is that right? But isn't the horizontal asymptote at y equals 0, 2? Right? And it's still 0, x equals 4, 4, 0, x equals 3. That shouldn't be the case. Numerator equal to 0. Did I do everything right on the x-intercept?
Yeah, you did.
What's missing? What am I doing?
Well, just look at that. It's not at home.
Yeah, it should be. There should be. Let me check. Interesting. Okay. I mean, it does go through it, but then the power on the bottom is bigger than the power on top, right? I think we've kind of found like an exception to the rule here. Because here's a Desmos graph. And because this is, well, I'm confused at it,
Yeah, it's odd.
right? So I guess it's, for here it's fine, but for here it's not. We did find a glitch in the system. All right. I mean, I guess it is what it is here, but I guess the horizontal, so maybe the horizontal asymptote has more than, I mean, it could cross at any time. What's the purpose of horizontal asymptote then? You know, it's like, yeah. All right, anyway,
Happen to be some test, right?
no, I mean, I have to double check because I thought it was like I thought it was just in the middle. I always thought it was just in the middle, right? Where you could cross the whole, but I guess it could happen anytime. So, but yeah, I'll double check and make sure that if you guys get problems, the only time you could cross the horizontal asymptote will be the bit in between the vertical asymptotes, okay? So, just so you know, all right? Yeah, that's kind of interesting. So, all right. So you plug in points here. You plug in points, you have what, -1. You plug in -1, and you plug in 1, 1.5, and 2. Okay. So you plug in these points and you'll see that, well, first, this one is going along here, right? 1 and 2, there was like a parabola of some sort. If you just draw some kind of parabola, you're good. And then this one was going up and across the horizontal asymptote. Okay. Cool. That's a good problem. All right. Number 3. You guys good? Yeah. I think you should, yeah, at least for the middle part, you should, but maybe put 1 point. It kind of just gives me your line of thinking, but yes, I would like tables on this, on all the problems, except like a problem with number 1 where, yeah, like you have a linear equation, that's fine. But for a problem like this, I think you should have a table. Huh? All right, let me double check this one before I'm all paranoid now. All right, let me double check this one. I know. All right, let's try this one. All right, this one should be okay. All right. So number 3, you factor, right? You factor here. It's x minus 3, x minus 2, all over x minus 3, x minus 1, right? Is that right? Yeah. So this cross out, right? So we're gonna have a hole at x is equal to 3, right? This is a point. And then we graph the equation. Our new equation is x minus 2 over x minus 1. So our vertical asymptote is at x is equal to 1. So we're gonna graph, we'll graph it here. I'm gonna skip every other spot. This is 1. Horizontal asymptote, the powers are equal, right? The power on the top is equal to the power on the bottom. So what happens? You can take the leading coefficient, right, of x squared and x squared, or use x and x. And what happens? It's y is equal to 1. So at 1, it's at 1, 2. That's where the graph hits the, yeah. That's the, sorry, that's the horizontal asymptote. Cool. So from that point on, you use the tables pretty much to graph. This one's pretty straightforward. You just have to maybe put 2 or 3, or actually, let's use the intercepts. Intercepts here. Let's get the y-intercept, where x is equal to 0. So we put 0 here. And we use the new modified equation. it would be 0 minus 2 over 0 minus 1. It'd be 2 over 1, which is 2. So 0, 2 is right here. Remember, I'm skipping every other, that's why, so. I should draw the graph a little bit darker. This is the y-axis, this is the x-axis. And then when we make y equal to 0, how do you have to make x minus 2 equal to 0, right? So x is equal to 2. So at 2, 0, this is where our graph hits the x-axis. The intercepts help us a lot in this case because all we have to do now is just move along the asymptotes here. And you will see the graph. I would maybe graph a few more points just in case. But this should be it. Sorry, I crossed the, my bad, I crossed the, man, I made a mistake. I crossed the asymptote.
You're going by half steps, right?
Yeah, so, or every other. So like,
You're
eh,
gonna do 1.25.
do I go up 1.2 right here?
Yeah.
Okay, so it should be right there. Thank you. Let me erase it. Cool. Good. Any questions on that? Okay. Yes. Oh, the whole. Yes, the whole. Is that what you asked?
Oh, yeah, I was gonna ask if there's two vertical asymptotes.
In this case, no, because we crossed out the x minus 3. That's why. If we didn't cross out the x minus 3, there would be 2 vertical asymptotes.
Oh,
Okay. So, but we have a hole though at x equals 3. And so you want to plug in x equals 3 here. It's what? We plug in 3. Let's plug in 3. 3 minus 2 over 3 minus 1. Be 1 over 2. So it'll be 1/2. So 1, 2, my graph sucks. 3, something like that. So it'll be somewhere like right here. Okay. So make sure you fill in that hole once you're done. You good? Let me know. You guys good? Yeah. All right. And number 4, last but not least here, let's do that equation that I put up. It is not this one. It is x squared minus x plus 4 all over 2x plus 2. You factor this, you can't. You can factor out the bottom, but you can't really factor out the top. So there's really no use in factoring in a way, but in the sense that you're not going to simplify the equation. All right, so because if you x minus 4, there's no factors on the top, correct? So what you need to do is get the vertical asymptote now. Vertical asymptote is 2 and then x plus 1, right? You factor that out. You factor out the 2, and you make x plus 1 equal to 0. Subtract 1, so x is equal to -1. So at -1, I'm going to draw these out a little bit better. So this is the y-axis. This is the x-axis. Then at -1, I'm skipping, so this -1, I'm going to have a vertical asymptote go down this way. In the horizontal asymptote, what do? You make, since the power on top is bigger than the power on the bottom, there is none. However, for the slant asymptote, because what, the power on top is 1 bigger than the power on the bottom, you have to use long division to figure this out. So what happens here? What number times 2x equals x squared? It'll be 1/2 x, right? So it'll be x squared plus 1 x. 1/2 times 2x is x squared. 1/2 times 2 is just 1x. You subtract it, this becomes a minus sign, so it'll be negative 2x plus 4. What number times 2x equals negative 2x would be minus 1, right? So it'll be negative 2x minus 2. Minus, it'll be a plus plus. So that will be 6. So we just have to worry about this right here. Our slant asymptote is y is equal to 1 over 2x minus 1. Let's graph this here. Minus 1 is right here. Go up 1 over 2. So you're gonna do something, it's gonna look something like this. Are there any questions on this? You good? All right, then you want to maybe look for the intercepts. Okay, maybe that could kind of help you out with this. All right, so let's look for and remember you're doing this on the simplified. Oh no, there's no simplified one. So let's go with the y-intercept. Again, is when x is equal to 0. Again, it's a point. So this will be what? 4 over 2, right? 0 squared minus 0 plus 4 over 2 times 0 plus 2. So it'll just be 4 over 2, which is 2. So 0, 2 will be our, I'm gonna put this in blue. So 1, 2. And then let's try to find the x-intercept. The x-intercept is where what? Y is equal to 0. You make the numerator equal to 0, so it'll be x squared minus x plus 4 is equal to 0. Can't factor, but we can use a quadratic formula. Negative, so let me just, a is equal to 1, b is equal to -1, c is equal to 4. So it'll be -1 plus or minus square root of -1 squared minus 4 times what? A is 1, c is 4, all over 2 times 1. How do you know right away that there's going to be imaginary roots on this one?
It's gonna be negative.
Yes. So inside the square root, which is called the discriminant, okay, it's going to be negative. All right. So you don't have to solve this out. Once you realize that there's going to be a negative inside the square root, there's going to be imaginary roots. All right. Cool. So then how do we find the other points? Or how do we find the other point? You want to go back up here and maybe do negative and plug in -2 into the equation and see where it lands. All right. So let's plug in -2. So it is -2 squared minus -2 plus 4 all over 2 times -2 plus 2. This will be 4 plus 2 plus 4 over -4 plus 2, 8, 10 over -2, which is -5. Okay. So at -2, -5, that's our next point here. So let's go back in here. This is 1, this is 2, This is 3, this is 4, this is 5. You'll have a point like right here. So where do I know that where the graphs are gonna be? Well, we have the y-intercept right here. So it's gonna do something like this. And it's gonna do something like this. Again, you may want to do extra points just so that you get more accuracy, you know, kind of thing, and just want to make sure. But for the most part, I mean, you're good. All right, any questions on this? Good, all right. We can stop the recording.